Hi everyone and welcome to this week's webinar. My name is Hannah. I'm a software specialist here at Strucsoft Solution, Great Tech Group, and today's topic is Accelerate Steel Design and Fabrication with MWF and Howick, featuring MWF Pro Metal or Advanced Metal. Here's what we'll be covering in today's session. Revit and MWF modeling. It all starts with the Revit environment. As you may know, MWF, which stands for Metal Wood Framer, is an automated Revit-based BIM framing solution created specifically to framing your Revit model for walls, floors, ceilings, and roof trusses. Today's presentation is specifically tailored for Howick outputs. I'll be showing you some of the tools you need specifically for Howick. Next, we will be uploading from Revit MWF into Onyx. Onyx is a cloud-based environment that has shop management tools, stacking and bundling, and CNC editing. It also generates CNC outputs as it acts as the link between the model and the machine. CNC outputs and editing. Before you make the final CNC output for your machine, you might want to make last-minute changes without having to go back to the Revit model. From Onyx to Howick, our special guest, Nick Cobre, who is the CEO of Howick, will walk you through how to create that panel with your Howick machine. The next portion of this webinar, we're going to be jumping into the Revit environment to talk about the following webinar bullet points. First of all, today we're talking about accelerating steel design and fabrication with MWF and Howick. A very big thank you goes out to Nick Cobre for joining us today. And here are the webinar bullet points. We're going to be loading Revit Howick families into the Revit project. After that, we're going to be placing Howick families into the MWF panels for walls, floors, and trusses. We need to apply the correct families to opening, markers, horizontals, and K-bracing. We have to set up the whole series correctly, and then we're going to be uploading the panel into Onyx. We're also going to go over something we talked about in the past, a previous webinar. We're just going to follow up on a webinar that we have previously done. It was in 2022 for Howick telescopic panels. I won't be covering everything, but I will be covering a few things, just a reminder of the previous webinar, which we will be jumping into before the Onyx portion of this presentation. Let's jump into the 3D environment and take a look at our model. This is a small project that we have prepared for today's webinar, and it has multiple panels. It has just a few trusses here, some floor panels as well, and we're dedicating this webinar to specific Howick related settings. To start, we do have to load the correct Howick families that we will need for our project. To do this, I just want to show you where to find them. If you go to the first button where there's the MWF logo and click on this little arrow, if you go to Home Directory, this takes you to a specific file location. This folder will be found in this PC, Local C, Program Data, Strucsoft Solutions. I'm using Revit 2024. We're looking at walls, framing components, Imperial, and MWF standard. These families here in the standard folders are generic families that you can use regardless of your machine. They're just generic families. I will talk to you about this one here, the BIMSF SSMA-S. So this is an S profile, and this one right here is a T profile. You can use any one of these two families for Howick machines, but if you wanted Howick specific families, we have those as well. I just want to show you where to find them. If you go one step up into Imperial and click on MWF manufacturers, here you'll find families that are third-party related families if you're using Howick. So this is the family that you would use for BIMSF Howick horizontals. This is the family, or these are the R families that you would basically be using if you are creating telescopic panels, which we will talk about later. For stud families, you can use this one over here. And you can also use this one over here. This is for the track. And basically, every one of these families can be used for Howick, and you can use our generic S and T families. I just want to highlight that you will receive out of the box these families, and a lot of them come hand in hand with the TXT file. If you double click on the TXT file, it looks like this. Every single one of these rows that you see over here represents the physical characteristics of a type that you can expect in this family. The first portion over here is just the name, and then these numbers represent the physical characteristics of that member. This looks like a catalog, basically. When you insert this into Revit, which I'm going to show you in a little bit, you can pick the ones that you need and insert them into your file. If you don't find the family or the type that you need, you can recreate your own just by doing this. I'm going to just select one, Control C on my keyboard, enter, Control V, and then you can change the name over here. You can call this whatever you like. You can even call it test. And then you can change these numbers to change the physical characteristics of that member. The first portion here is the return. The second one is the BF, and then there's the D, the TF, and etc. I'm not going to save this for now. I'm just going to close it. And now I'm going to show you what this is going to look like in the Revit environment. Before I do that, I do want to just mention that I'm using imperial families for today, but we also have metric families as well. I'll just minimize this. And now I would like to insert the families into my project. To insert the selected families, I need to go to Revit Insert, just like any other Revit family. I'm going to go to Load Family. And if I go to the bottom left, this will take me to that location that we just saw. Under framing components, imperial or metric, I'm using imperial. I will be using Howick families for today. So MWF manufacturers. I will be loading some horizontals. I will also be loading some tracks and some studs. So I'll select these three using Control on my keyboard, click on Open. And here I will start to select the family sizes that I need from this list for the S, for the track, and for the horizontals. To do that, we simply select what we would need. I've used Control on my keyboard to make the selection. Click on OK, and then these families will be loaded into my project. I've done that already, so I don't have to do that again. So I'm just going to click on Cancel, and I already have loaded everything that I need for this project. So this portion, downloading the families, is completed. Now let's talk about adding these families to our panels. Let's start from scratch. To start, you do have to have your model ready. I've already created my project using specific wall types, generic wall types that you can find in about any regular Revit template. I'm using this specific wall type for the exterior walls, and I've used something else for the interior walls over here. I do want to highlight something very important, that I've already added my joins to all my walls. I've already numbered my panels in an organized way. And before I created my panels, I've already created splits. So I have split my walls into the sizes that I need before I upload into Onyx. Let's start from scratch. I'm going to make a copy of this wall over here. Just going to bring it over. I'm going to use Create. I'm going to use an out-of-the-box template, light gauge. I will set it as active, hit close, and then click on Create. I'm just going to close this for now, so I'll click on OK, and we'll come back to the properties in a little bit. So this is the template that is available out of the box, or one of the templates that are available out of the box, and it's using these specific S families and these specific T families. To change them into the Howick families that I need, I'm going to select one member of this panel, go to the Properties menu, and select the families that I need from this drop-down over here. So when I click on this drop-down, Everything that I have loaded, all the families that I have loaded into my project are going to appear over here in this dropdown, where I can simply select the one that I want by clicking on it. I'm just looking for the Howick family that I need to use. I'm going to use this one for the horizontals, this one here for the studs. For the tracks, I'm going to use some S profiles for the tracks in this example. I'll be using this family over here and this one over here. Then I'll click on OK. And now I'm using the correct families for my project with regards to the studs and the tracks, but there's more to talk about. The next thing I would like to talk to you about is openings. So when you add an opening, and let me regenerate this panel. You need to make sure that you're using the correct profile. So this one right here is still using the default. To change this, I do have to go back into my properties, go into miscellaneous, opening framing. I'll go to openings and I'm going to come back and talk to you about changing rules. But first, let's start over here. So this is the most basic or the simplest option that you have for your openings over here. You can specify what you want to do for window, doors, and openings. I'm just going to use for all openings. I'm going to change the header type and the sill type from over here. I'm going to use this one over here and this one over here. And then I'm just going to click on close and then OK. And now I'm using the correct family for the header and for the track. If I wanted to add a specific opening marker, let's just zoom in over here. So for this specific marker, if I go to miscellaneous and go back to opening framing, I'm using the opening framing condition map for the windows, truss header, symmetrical V. I do have to go into marker manager, into openings, and make sure that the marker that I'm using, if I double click over here on truss header, symmetrical V, I have to make sure that I'm using the correct families under header family, diagonal family. Of course, you have to make sure that your settings are correct. For the cripple family, you also have to choose the correct one. And here under general, anything else that you would need to change, such as, for example, the jack, king, and sill, have to also be specified over here. I'm going to click on OK, OK, and OK. A few more things to talk about. I'm going to delete this window over here, and I'm just going to regenerate. And I would like to talk to you about adding horizontals and K-bracing. To add horizontals to your panel, you need to go to miscellaneous, horizontals, click on edit. I'm going to add horizontals starting from S1. You can start from end 1, but I'm going to start from S1. And I'm going to reference it to the end. So offsets from start, offset from end, from S1 to E2. I'm going to skip the first one because I'm going to add a K-brace. I will make the justification structural centerline, and it's very important to choose the correct family from here. I'm going to use this Howick family. I will just add one horizontal, and if you click here on add, it's going to create a random name for you, or you can add your own name. And I'm going to split horizontal studs, add a stagger, update, hit close, and then OK. The next thing I would like to add is this K-brace that you see over here. So let's go back to properties, miscellaneous, K-brace, hit edit. I'm going to start from E1. The first thing you have to do is add a name. So I'm just going to call it 1. Click on Add. I'm going to make it start at E1. Make the sections 2 sections. You can invert it if you like. And you have to make sure that you're using the correct family over here from this drop-down. And over here for the horizontal stud. You can click on Modify, Close, and then OK. The last thing I want to talk to you about is adding the correct hole series for Howick. So I'll select one member of this panel. I'll go back to the Properties menu. And this time, if I jump into Miscellaneous, I'm going to go to Hole Series, click on Edit. Here I can specify the hole type that I want to use. I've already created the hole type that I would like to use. I'm actually going to create a round hole. So you specify that it's a round hole. You give that round hole a name. And then you have to put in the correct CNC code over here. So this CNC code you would receive from the manufacturer of the machine. For this specific hole type, this is the operation code that we need. You have to make sure that it's filled in over here. And then you click on Add, and here is where you edit the shape from over here. So you add the diameter that you need from over here. And I'm going to add it vertically, starting at a 6-inch offset. This is the spacing I want to use. And then you have to select the hole type, the edge clearance and depth offset. You can only punch rotated studs. You can punch rotated studs in orientation direction. So you would have to click on Add. If you want to make changes, you can make changes and click on Update and then Save and then OK. And this is the result that we were looking for. For this example over here, I have also added this flat strap. To add this flat strap, I have to load the correct family. And then I'll go into Properties, Miscellaneous, Bracing, click on Edit. I'm going to use X braces. These are the settings that I'm using. I'm using exterior. You have to select the family over here from this drop-down. I'm using the top elevation for E1 and the second elevation E2. And I'm going to include the cutout. And this is the setting that I'm using. I hit Close and OK. And now we're ready to talk about floors and trusses. For floors, I'm using this specific Howick horizontal. If I switch to the floor module, for my floor, I've started with this floor over here. I went to Create. I've used light gauge, frame it now. So I'm using the out-of-the-box light gauge, hit Create. And then I've switched the correct families from Properties, Member Properties, the end tracks, end joists, side tracks, and joists. Howick, then OK, and joist. For the trusses, I'm going to make a copy over here. I'll go to Create. I'm going to use the default wall trusses, hit Frame It Now, click on Create. I'll auto rename all. The first thing I'm going to do is rotate this panel. So I'm going to use the rotate tool. So Revit rotate, enter the angle that I need, and regenerate. And then I'm going to need to use the correct families. Right now I'm selecting an assembly. So MWF is going to create multiple assemblies with the same number because they're basically the same assembly being repeated. This one is going to be different, and this one here is going to be the same one. So basically you have two types of assemblies. You'll have to edit both of them. I will be using this specific size over here. It's an S800S, 162/5450. So I would need to add it under Properties. Member Properties, you have to modify end joist, side tracks, joist, and cutbacks. These are the member sizes that I'm using. I'm just going to use this one for now. And I've applied it to all so that the bottom chord, webbing, and heels are using the same one. But if you wanted to add more, you'd hit Add, and you can add them over here into your list. But I'm just going to be using this one for now. I'll hit OK. For trusses, if you wanted to engineer this truss, you would have to use our out-of-the-box truss families. I'm going to show you where to find them. If you go to the first button, Home Directory, click on 2024 Trusses, Framing Components, Imperial. For manufacturers, these are the only available options for manufacturers. So for Howick, you would need to use one of our standard. I'm using S trusses and T trusses. You would have to use one of these two options over here. I've already loaded them. Because if you're going to be running advanced metal truss design, you would have to use one of our out-of-the-box families. Other than that, it would fall under customization. And now that we're done with creating our model, we're now going to upload this model into Onyx. Before we jump into Onyx, let's just jump back in time to our previous webinar that talked about Howick telescopic panels. So I'm just going to click here on the 3D view and talk to you a little bit about telescopic panels. I've already uploaded this panel over here, so you'll see that this is highlighted in red, just the same technique that we talked about before, where Nick is going to be using this panel in a little bit. But just a quick recap that you would need to use the correct families, especially the R families over here, for your telescopic panels. And you would need to add your markers. If I click on Properties, you'll also have to select the telescopic panel, which I have already pre-created and discussed in a previous webinar. I've created something for horizontals, and I've created something else for verticals. And just a reminder where you can find this webinar. If you go to the first button and click on Wall Video Tutorials, and if you click here on Strucsoft Great Tech Group, you can search for our Howick webinar. And this will come up after your search, and this is the webinar that you would have to go back to. So we would like to invite you to check out this webinar entitled Howick Telescopic Panels from Design to Precision Manufacturing. I'm going to click on Onyx Upload Center, click on the first icon button over here. This takes me to our Onyx website where I'm going to log in to my account with my username and password. I'm going to add a project. I'm going to call it Howick Webinar and hit create. Now I've created an empty project called Howick Webinar, and I can go back to the Revit environment and upload it there. Next, I'm going to click on Show Upload Center, log into my account. And now I've selected the project that I had just created, and now I'm ready to upload this project into this location. Before I talk to you about upload sections, I'm actually going to click on Upload Panels. This is the dialog box that allows me to upload new panels into Onyx. This is called the Panel Upload Manager. I can select whatever I want to upload from over here. If I had made a selection in my project and then clicked on Upload Panels, I'm only going to see the panels that I had selected. But because I haven't made a selection, I can just filter from over here. I can filter by floor, truss, or wall, by level, by area if I had defined an area, and this shows you how many times you have already uploaded the panel. Over here, under Onyx Panels, this would show you anything that you have previously uploaded, but because I haven't uploaded anything, it's empty. I'm actually going to upload everything all at the same time, so all my panels all at once. I just want to check component status and talk to you about what this means. So if you select any one of these panels, you can see the components that make up this panel. So you'll see here, for example, for panel 43, this is made up of some Howick horizontals and, for example, a flat strap. The green tick means that this has already been uploaded into Onyx as a component. If you receive an X red icon over here, this means that you would have to upload your component. And to make life easier, you can just click on Not Uploaded, and you'll see any component that has not been uploaded. If you click here on Component Upload Manager, which is the same as clicking Upload Sections, you'll see what components you have that have not been uploaded into your project. And if you click here under Onyx Components, you'll see everything that has already been uploaded into Onyx, and I have already uploaded everything. So I'm just going to hit Close. I'm going to click on Upload. Then you'll get this upload summary. I have successfully uploaded 97 wall panels, 2 floor panels, no ceilings, and 21 truss panels. It didn't skip anything, which is good. So I'll click on OK. Before I hit close, I just want to show you that under new panels, there's nothing there because I've already uploaded everything. So here under Onyx Panels, you can see that I have uploaded everything. And if I wanted to change my mind and delete something, I can do that from over here. But for now, I'm just going to hit close. And here in my project, you'll see this red indication over here, and it's going to show you that this is a locked panel. So if I wanted to make any changes and go back here and try to make changes in the properties, it's just going to give me an indication that this is a locked panel. So I would have to go here to Settings, View Lock Status. It's going to show me that this is a locked panel. It was locked by Hannah, and the reason why this was locked, which was that this panel has been uploaded into Onyx. I can then make the decision to unlock this panel, make my changes, and then I can send it back into Onyx. Let's jump into Onyx and take a look at our project. This will take me to the panel manager where I can see all my wall panels over here in this list. My floor panels are going to be found over here. I have no ceiling panels, and I have these truss panels over here. In the project viewer, I can create sequencing and I can create stacking. Load panels. Let's make this fine. And here you can filter floors, trusses, and walls. And here you can see the entire project has been uploaded. You can create sequencing and stacking. I will not go over that today. We invite you to take a look at our other webinars that cover sequencing and stacking. I'm just going to jump into the panel manager. Before I can download CNC for any one of these panels, I'd like to jump out of projects and start from the very beginning by going over some settings. So over here in settings, you have to create your CNC machine setting for your Howick machine. Under machine type, it's roll former. We're talking specifically about Howick today. And Nick and myself have already created some settings that we're going to be using. We're using an extenda for today. But to create settings, you have to click on Add Settings. You have to specify a setting name. The display units is set from over here from unit settings, so it's from outside this section. It would be under Onyx settings. The output measurements are in inches for today. And the machine options, you have to fill them out from over here. This is actually going to ensure that you create the correct CNC output for the specific result that you would like to achieve. So over here, for example, we're going to be using dimple A instead of dimple if the thickness is more than a specific thickness. The flange slot separation distance, web punch width, lip notch width, swage tool width, dimple minimum edge distance, dimple minimum edge distance X ratio, tool tolerance, web hole side to center dimension, web hole center dimension is web hole center diameter, and web hole side diameter. Under general, you can include panel ID and frame set. You can use stud spacing tolerance if you like. You can use a default profile or not. Profile description, use version 2, add sequence number to output file name. You can use a slotted dimple. I can show you that in a little bit. Or you can use dimple 2. I can show you the difference between those in a little bit. Vertical joists are structurally critical. Create swage at flat straps. You can double tab at intermediate members. As for wall panels, you can replace dimples with flange slot on top track, add extra flange slots on ends of top track. You can add door courtesy cut and add courtesy lip cut. Output options, top, bottom, left, right. This is what I'm going to be using for today. And then when you click on create, it's going to create a new setting for you. I've already done that. We've already created the settings that we're going to use. And now the next step is going to be to go back into settings, component types, and specify what machine setting you need to use for these specific components that we have uploaded into Onyx. Just remember that you can create multiple settings for the same machine. We've created multiple settings for Extenda, and we've already assigned them to specific families. To assign them to a specific family, you would select the families, you would click on Assign CNC Machine, select your machine, we're using a Howick, and you would select the settings accordingly to what you need to achieve. I'm going to hit close because I've already pre-assigned them. And now I'm ready to go back into my project. When you click on a specific panel, let's say panel 24, over here under members, you're going to be able to see what this panel consists of. So these are all the members of this panel showing up over here. You can see the panel name, the description, the section shape, the gauge, additional information, and over here you can see which machine is going to be used for that specific member. Before you download CNC, we do need to talk about the CNC editor. So I'm just going to click here on CNC editor. I'm going to load panels, and here you can see a list of all the panels that exist in my project. I'm just going to jump back to the Revit environment and take a few references from my 3D model. Let's start with this panel over here, which is panel 32, and take a look at it in the Onyx environment. So I'm going to type in P32, and this is the panel. And this is how Onyx is going to read it based on the settings that we have set up for this panel. So when I select one member of this panel, you can see the details over here. You can see that the machine that's going to be used is this one and this specific setting. You can see the family type, family symbol, and very importantly, you can also see the CNC settings that have already been populated. So for example, this one over here is a lip notch. So Onyx knows that there's going to be a lip notch over here. This right here is a dimple. So right now we're using this specific dimple. I can make changes over here. I can use a bolt dimple if I want. So I can make CNC changes. But Onyx already knows what to do. Because I've already assigned these machine settings, you'll find that these CNC settings have already been added. For example, this one over here, there's a lip notch. And you can see under Code Viewer what the code is going to look like for that specific machine setting. Over here in this example, you'll see that I have two studs over here, and you'll see that Onyx has recognized that it has to place a lip notch for the two of them. You can see if I select it, this is a round hole. And if I just scroll over here, you'll see that there's the service hole. This is where what we have added in MWF. Onyx can recognize it. And you can make changes or last minute changes. And you can switch from one CNC edit to another from here. You can also add some functions. So under General, if you click here on LGS operations, you could add a dimple, a flange, web holes, round hole, bolt hole, slot hole, and flange bolt, lip, web, truss, dimple slot, swage, and double tab. Anything that you can see that is available means that this is a setting that is available for your machine. Anything that is grayed out means that it's not available for that specific machine or that specific machine setting. If I decide that I want to make a change to my setting, so let's say I want to change a dimple in this setting over here for extend the 6-inch. This icon here helps me view it, and this one here, I can make a copy, and this one here would delete it. I'm just going to duplicate it. I'm going to call it something else. Two. And over here, instead of using slotted dimple, I'm going to use dimple 2. I can make more changes over here, but for now, I'm just going to click Save. And now I've created a new setting. If I go back to my settings, component types, Click on Save, and then go back to my project. Let's go back to CNC Editor, load panels. Let's go back to the same panel. And if I zoom in over here, you'll see that the dimple type has changed based on dimple 2, what I have just specified in my settings. I can change it over here back to dimple instead of using dimple 2. Let's take a look at other options in our project. Let's talk about this scenario over here where there's a flat strap. So this is panel 33. I'm going to discard my changes. For panel 33, first of all, I just want to highlight that the flat strap is not going to be assigned to a specific CNC machine. The reason is that this flat strap or strap bracing is going to be manually cut. So it's not going to be generated with a Howick machine, but you can show it in Onyx. The other thing, if you don't find the correct CNC automatically created for the flat strap, you can make changes over here. I'm just going to delete any unwanted swages that we are not going to need that have been automatically generated. So there might be some cases where you would have to go into the CNC editor and manually make your edits. You might also need to add your own edits like this and add the swage to the correct location. Delete what you don't need. And then when you're done making your changes, you have to go back to General, Save, and saving will save this as a draft. It won't be in the final CNC document. But then if you publish, it means that this is going to be saved. You can click on OK. And then you can go to your panel manager. Let's find that specific panel. So I'm just going to filter P33. There it is. And then you can create CNC. So when you click on Download CNC, you're going to get a specific folder that is a zip folder that's going to be downloaded in a specific location that has the CSV file with the changes that you have just created. So this is the CSV file for that specific panel. And you can see the swages, you can see the dimples, the lip cut, and this document over here. Let's load panels again and take a look at one of our trusses. For our trusses, you can see over here that there's a truss cut that has been automatically added. This is not something that I did with MWF. This is something that Onyx recognizes that it has to do. You can also see that we have these dimples, and you can also see that we also have a lip notch over here and a swage over here. If you take a look at the floor panel and you zoom in, you can see the dimple that is being used and the lip notch. So here's the dimple. Here's the lip notch. Here's the dimple, the lip notch. If you go back to Panel Manager, let's take a look at Panel 32. Download CNC. And this is how it's going to look. You can see the default profiles. These are the top, bottom, E1, S1, and etc. And you can see over here the dimple and the swage, the lip cut, and etc. You can also see over here under members that this has been downloaded. This concludes our technical portion of today's demonstration, and now we're going to hand the mic over to Nick.
Hello, I'm Nick Cobre, CEO of Howick Limited. We make roll-forming machinery for the construction industry that produces floors, walls and trusses. We've had a long history with the team at Strucsoft, and today we're talking about Onyx, their management system that integrates with our machine to make projects easier to run. I'm going to give a really brief look at some of the Strucsoft features that we use, and then Hannah will also give some more detailed features and show you the whole system. In this particular project, we have just a couple of very simple panels that we're going to load. One of the greatest features for us is that if you do not have access to Revit or MWF software directly, Onyx allows us to look at panels and edit and adjust panels and select which machine we're going to run them on. So you may have two different machines that have different tooling names and different tooling properties. Through the Onyx system, we can select which machine we want to export those files to and then export them as files to run. So you can see in this panel here, we can view the panel, we can view all the connections. One of the great features that we have here is the fact that we can add features to the components. So we can actually edit some of these files, and we can also view the CSV code that goes to the machine. So we can select a component and it will highlight which piece it is. So for instance here, say I wanted to add some bolt holes to a component. I can actually select the component, add a bolt hole, and then either drag to position or type in the position. This is really great for our operators if they need to add additional holes because the design team has either missed them or has not placed them in the first place. So you can see I've dropped those holes in there. Then when we export the CSV, those holes are in position. So I can save that component now and export. So this can be done at the desktop in the office or potentially on the machine itself. I would limit access for the machine operators so that they do not change things without permission. And once we've got our panels, which we've got here, panel 3, I can download my CSV file and it will download onto the system, ready to run. So download the file, then we can open the file on the machine. And we can review the files before we run them as well. Once we've got the file on the machine, then the operators can select the file to run and run the components. The components all run in a sequence ready for assembly. As you can see here, this is one of our telescopic extender machines, which is quite a unique system that allows for non-load bearing panels that are adjustable to fit into different spaces. So you can see the operators here running the pieces, screwing them together straight off the machine.
Thank you for our special guest, Nick Cobre, for joining us today. And this concludes today's webinar. We hope you enjoyed it, and we'll see you next time. Bye, everyone.